Here are some more examples for predicting type of reactions. I just made these up like off the top of my head. So I'm just going to go through and I'm going to show you how I would complete them if there were 5. So you should have your types of reaction notes up maybe just so that you can look back and reference it unless you've taken the time to memorize all the types. But assuming you haven't done that, you should have that list up so that you know what to look for. For the first one, I have CH4, that's methane, plus O2. So looking at the reactants, you should be able to predict the products based on the type of reaction. So first thing you should do is try to identify the type. When you see a hydrocarbon, so carbon and hydrogen, plus O2, that is a combustion reaction. Any hydrocarbon, so it could be C2H6, it could be C3H8, any hydrocarbon plus O2 will always give you CO2 plus H2O. Every single time you're going to get carbon dioxide and water. So once you've identified something as combustion, these are always the products you should write. There is no other choice. If you are going so far as to say like, well, I have 4 hydrogen over here and only 2 over here, don't worry about that. We're going to get to balancing in the next couple of weeks. So for right now, we're not worrying about balancing reactions, making sure that there's the same amount of atoms on both sides. Right now, we're just predicting products. So once you've identified something as combustion, you are always going to have the answers CO2 and H2O. This next type, I'm given 2 elements. You can actually see the last 4 problems here. So an element means that there is only one type of atom. So here I have sodium plus oxygen. There is only one type of element in each molecule. Here it's just sodium and here it's just oxygen. That's it. Looking at the rest of these, I have carbon and hydrogen. That's a compound. In 3, I have magnesium and chlorine, that's a compound. In 4, I have sodium and chlorine, and then in the other one, calcium and oxygen. And then in the last one, I have potassium and iodine. So number 2 is the only one where I have 2 elements. When you have 2 elements being added together, you have a synthesis reaction. So synthesis means you're going to put the elements together into a compound. Well, when we write a compound, we have to write it based on their charges. The answer to this is not NaO2, right? We don't just put those things together. That's incorrect. I have sodium and I have oxygen, and I'm going to write the formula based on the charges. So I put a periodic table down here at the bottom. Whoops, you are going to want to pull up your periodic table to do these problems. And just as a reminder, +1 is in group 1, +2, we have +3, and then, whoops, -3. For nitrogen's column right here, -2 for oxygen, -1 here, and then 0. And then just as a reminder, these 2 are +2, and this one here is +1. So our first one was sodium, so that has a +1 charge. So I'm going to go back up here and I'm going to write sodium with a +1 charge, and I'm going to add that to oxygen. Oxygen is right here with a -2 charge. So remember, you have to recall back in your brain a little bit because we did do this a while ago, but our charges have to equal 0 when they're added together. So that means I'm going to need to multiply the sodium times 2. I also showed you guys the crisscross formula, so there's a 1 here, the 1 goes there, and the 2 goes here. So that equals Na2O. That is the correct formula when you add sodium and oxygen together. Your answer is Na2O. So you're going to have to do that every single time except for combustion reactions. For combustion reactions, it's always CO2 and H2O. For every other single compound, you're going to need to look up the charges and you're going to need to write a formula based on those charges. So this is our answer for the product, and this is our answer for the type of reaction. Again, we're not balancing it yet. We're going to get to that at a later point. The next one, number 3, here I have a compound. Magnesium chloride is a compound because there are 2 types of atoms And here I have potassium by itself, one type of atom. So first thing, or what I'm going to identify this is a single replacement. It might also be called single displacement. That might have been in your notes, and that's fine. Single replacement. So first thing I'm going to do is I need to find out, is potassium going to replace the magnesium or the chlorine? I don't know. I have to figure out which one it's going to replace. So I'm going to go down here and I'm going to say, okay, here is potassium. And it has a positive charge, right? It's a metal with a positive charge. So is it going to replace magnesium, which is right here, which is also a metal, or is it going to replace the chlorine, which is over there? So metal will replace metal. Because magnesium is also positive, potassium is going to replace the positive one. So the potassium is going to come in here, and we'll have potassium bonded to chlorine, and then magnesium by itself. So magnesium gets kicked out, it's by itself. And then our compound is what we're going to write. I have potassium. Potassium has a +1 charge. And then I have chlorine. And chlorine has a -1 charge. So because they equal 0, I just need one of each. So there are my answers for that problem. Moving on to the next one. Here I have two compounds. I have a sodium and chlorine, two types of atoms in my first compound, and then here I have calcium and oxygen, two types of atoms in my second compound. So that means this is double replacement. Here, the positive ones are going to switch. So that means calcium, the positive ones are always written first, right? Calcium is positive, it's going to switch with sodium. Sodium's going to come over here and switch with calcium. So I'm going to have two compounds now as my answers. Here in this first one, I'll have calcium, right? Because that's going to replace the sodium. And calcium has it's down here, it has a +2 charge. And it's now bonded with chlorine instead of oxygen. So Cl. And Cl is down here with a -1 charge. So again, remember when you add the charges together, they need to equal 0. Right now it equals +1. So I need two chlorines. I need to multiply chlorine by 2 to get -2 so that it equals 0. Or I can crisscross. The 2 comes down here. The 1 comes over here. So Ca1, we don't write the 1, and then Cl2. Now for my other compound, remember the sodium went in and replaced the calcium, so I'll have sodium bonded to oxygen. We actually already did that before, but I'll do it again just to reiterate. So I have sodium there. And sodium's right here. It has a +1 charge. And then oxygen is who it's being bonded to, and oxygen is right here with a -2 charge. So again, they have to equal 0. I'm going to need two sodium for every 1 oxygen. So Na2O. And there are my two products for that reaction. Finally, the last type. Remember there were 5 types. We've gone through every type except for the very last one, which is decomposition. This is decomposition, and I can tell because it has only one reactant. Every other one of these had 2 reactants. Combustion has 2 reactants, synthesis has 2 reactants, single replacement has 2 reactants, double replacement has 2 reactants. Decomposition only has 1 reactant. And what am I going to do? I'm going to split those up into the 2 elements. So when you have decomposition, you're going to split it up into the 2 elements. If it contains a polyatomic ion, there are different decompositions that you will do. However, that's a more advanced lesson. We're going to stick to just binary compounds with 1 positive, 1 negative ion, no polyatomic ions. So I'm going to split them up into potassium and iodine. The only thing you have to do here, we don't have to worry about charges or anything. The only thing you have to remember is Huckleberry pheno. So That's the acronym that I told you guys about. That is your diatomics. It means that all of these, when they are by themselves, not in a compound, when they're in their elemental form by themselves, they appear in twos. That's a little acronym to help you memorize them, Huckleberry Fino. Or if you're more of a visual person, there's 7 of them, right? 1, 2, 3, 4, 5, 6, 7. And they make actually the letter 7 on the periodic table, starting with nitrogen over to fluorine down to iodine. They make the number 7 right there on the periodic table. And then there's 1, 2, 3, 4, 5, 6. The 7th one is hydrogen. So hydrogen plus these 6 are the 7 diatomics. So notice iodine is right here. It is one of my diatomics, which means I'm going to put a 2. Potassium is over here. It is not a diatomic, so I'm just going to leave it alone. And those are my 2 products for a decomposition reaction. I hope that helps. Please let me know if you guys have any specific questions.